All right, I am now finished with my experiment. I'm going to explain some of the data that I've gotten. So first question, how did the infiltration rate change with increasing time? Well, with me specifically, it started off with one of the higher rates of infiltration, but then after it kind of exceeded that for the next couple rounds, but after the minute and a half mark, the infiltration rate started slowing down drastically, and I'm assuming it was because of the water reaching its saturation. It was raining today, so that could have something to do with it. The average infiltration rate was 7.36 millimeters per minute. But like I said, there was a lot of variability between those numbers, especially at the end. So if it was 7.36 per minute, the hourly infiltration rate would be 441.6 millimeters per hour. So that is the infiltration rate in my backyard. Do keep in mind that it was raining today, so the water might have been closer to its saturation rate when I started than it usually would be. If there is a rainfall event and the rainfall is greater than the infiltration rate, what happens with the water? So if it's greater, a ton of stuff could happen. Firstly, it could just pool over. If the dirt is just kind of hard and doesn't allow the water to kind of seep in, it'll just pool on top, or the soil itself could get overly saturated, which can affect plant life. It could also cause some runoff, causing the soil to move around and like kind of start flooding out into different directions. And if it's lower, then the soil should be able to just absorb it usually and just go through its normal saturation infiltration rate as it does. The role of capillary action on water entering the soil. So gravity does have a big part to do in the initial entering of water, but capillary effect kind of helps that spread out against gravity. That's why you can see, like, when I put the water inside of the can, even the soil around the can and like even starting to get to the outside start getting a little wet. That is because of capillary effect. So not only does the water go straight down, but it'll even come up and out into the surrounding soil, helping kind of the while the soil gets saturated by everything. Um, the effect of vegetation on computing eye. If soil has large pores and small pores, which pores would the plant root take from water first? So vegetation does have a lot to affect. The plant roots obviously soak up their own amount of water, which will affect infiltration rate because it can change the factors in which how fast water gets seeped up and like how I'm measuring it as well. If a soil has large pores or small pores, the plants will usually take water from the smaller pores first because they tend to retain water for a longer period of time. And then last question, if we had the same soil on Mars, how will the Mars infiltration rate be different from yours? So it should be slightly less effective or efficient just because the gravity factor. Like I said before, gravity has a big factor in the initial infiltration of water going into the soil, and those first initial times might be a little less, but then after when the water does fully get saturated into the soil, the capillary effect would start taking place, and if it's the same exact soil, it should have the same properties. Do keep in mind that Mars does have differences in atmospheric pressure, so that may cause some difference as well. But yeah, thank you for listening to my project.